Greetings, my name is Stefan Sorger. I'm an instructor for data analytics and data mining courses. I'll be taking you through an example of how to prepare a simple data mining project presentation. The work is not intended to be a tutorial on data mining or on programming, but rather on creating compelling, data-driven presentations that communicate well with business audiences. For our title slide seen here, make sure to mention all the members of your team to give them all credit. We've made every effort to ensure accuracy and relevancy of the content. Nevertheless, we cannot control how the information is being used, so we assume no liability for the use of this information. In this presentation, I'll take you through how to build a data mining presentation from the beginning problem statement, through research and software development, on through conclusions and recommendations. You can see a typical agenda on this slide. We start with the problem statement, where we state our objective or goal of the project, along with the success criteria we'll use to determine if we've succeeded. In our case, we were working with a major U.S. retailer whose name cannot be mentioned due to privacy reasons, and who will refer to as Acme Retail. Their sales were down from previous highs. To resolve the issue, we recommend a market segmentation study using cluster analysis with the short-term goal of identifying 3 actionable segments. In the model selection slide, we state why we selected this particular model and not another, such as pricing analysis. In our case, we want to improve our engagement with the market, so we will apply cluster analysis for market segmentation. Specifically, we'll be executing Ward's model in R for hierarchical agglomerative clustering. We then give our audience an overview of what we'll present to them using a solution process slide. In our case, we move from background research and data collection on the left through cluster identification and interpretation in the middle to conclusions and recommendations on the right-hand side. In the research slide, we summarize the research we conducted to gather the data, such as surveying recent college graduates. In our case, we'll be collecting psychographic data on shopping beliefs by gathering responses on 6 statements listed on the slide. Statement 1, shopping is fun, Statement 2, etc. We'll be using a 7-point Likert scale for the responses, from 1 for strongly disagree to 7 for strongly agree. This slide shows the raw data from the survey, with 1 row for the responses from each person surveyed. We now start the software process by converting our Microsoft Excel file to comma-separated value, or CSV, format. This type of slide is optional in case your organization does not need to see this level of detail. To execute Ward's method, we follow the instructions given in the hclust hierarchical clustering help file. To do so, we read in the data, we calculate the distance matrix, and we develop the hierarchical tree. Note that the Ward function was replaced by ward.d2. This type of replacement is common with open source software, where software gets updated as needed. Again, not every organization will need to see this level of detail. For the visualization section, we want to include charts, graphs, tables, and other tools to give the audience a visual representation of the data and what it means. In our case, we show a cluster dendrogram of the data using R's plot function. We recommend visualization enhancements whenever possible to improve understanding. In our case, we have R draw boxes around the 3 clusters shown in the dendrogram. We now move to the model results section of the presentation, where we present our results. In our case, we'll show the membership of each cluster or segment. To do so, we use R's cut tree function to cut the tree into the 3 clusters we saw earlier. We continue the model results section by displaying the results of the cut tree function showing the respondents belonging to cluster 1. We apply our subset function to get a subset of the data. We repeat the process for cluster 2, and then again for cluster 3. We want to understand the cluster data, so we get summary statistics around it. In this case, the mean or average of the various columns of the data are what we want. Recall that the columns indicate the responses for each of the 6 statements. We repeat the process for cluster 2, and then again for cluster 3. We end the model results section with a table summary of the results. In this case, we show the means for each of the 6 statements for the 3 clusters that we have identified. To make the results easier to understand, we add bold emphasis to values that are significantly higher or lower than the average of the values. We also remind the audience of the statements so that they can connect the dots, from the averages for each statement to the actual statements themselves. With the model results completed, we now interpret the results in the Results Interpretation section. In our case, we notice that cluster 1 contains 3 unusually high or low values for statements 1, 3, and 5. When we examine the corresponding statements, we interpret those unusual values as indicating that cluster 1 represents experiential shoppers. We repeat the process for cluster 2, where the very high value in S5 indicates a strong don't care sentiment for respondents in that cluster. We repeat the process for cluster 3, where the large values of S2, S4, and S6 indicate a budget orientation. We now move to the situation comparison section, where we start by summarizing the results of the results interpretation with simple statements, one each for clusters 1, 2, and 3. Again, we're taking the audience through a very clear, understandable process. For situation comparison, we compare our model results with similar situations faced by other organizations. In our case, brand agency Landor did a project similar to ours, where they were asked to show that an initial generic customer base could benefit from cluster analysis so that we can understand differences among customers. Landor identified 11 segments, including engaged active shoppers, who are similar to the experiential shoppers we identified earlier. We continue the situation comparison with a second comparison, this time from the Mediterranean Journal of Social Sciences. The journal found 5 different segments, such as low engagement shoppers, similar to our don't care cluster, and mean-oriented shoppers, similar to the budget shopper cluster. For the final slide in the situation comparison section, we show a third comparison, in this case with the International Journal of New Product Development and Innovation Management. The journal identified several segments, such as females who want a friendly atmosphere and availability of food, and males who are more connected and concerned with sheltered access and safety. The journal also found differences based on income, differentiating between those generating more than 20,000 Great British Pounds and those making less. The higher income segment wants a good layout, a good selection, and high quality, whereas the lower income segment is more concerned about the shopping atmosphere. We close the presentation with conclusions and recommendations. For your presentations, make sure you state if you're able to actually achieve the goal of the project. In our case, we were able to conclude that we have satisfied the short-term goal of the project, which was to identify 3 actionable segments, each of which is supported by market research. We end the presentation with recommendations. In our case, we recommend making shopping more experiential to satisfy the experiential cluster, including food if possible. For example, Apple retail stores encourage customers to engage with the products, so you can use the apps in the store. In addition, many Apple stores are located in shopping centers with nearby restaurants, thus satisfying the need for including food. For the budget cluster, we encourage showing the value that shoppers get when purchasing goods. In Apple's case, their products exude style and quality, helping to justify their relatively high price tags. Again, the central point of data mining presentations, as well as any presentation, is to take the audience through an exciting journey of discovery. And what can be more exciting than data analytics and data mining? Again, thank you for watching this video. If you think it helped, please click the subscribe button.